In this video, we're going to talk all about quadratic equations and how to graph them and how to learn a few different properties about them. So you can see what I've got plotted on here right now is a basic quadratic equation, just written up here. I'm using this software called GeoGebra to do the graphing. It's free and easy to download. You can even put it on your phone. Okay, so there's a few things we want to know about a parabola in order to graph them nicely. It's nice to know where this point is right here, and we call that the vertex. Uh, we also want to know the axis of symmetry. That's where could you draw a line where the parabola acts like a mirror on either side of that line. I'll try to draw a bit of a thicker line here. I'll use blue. So this is the axis of symmetry. That's all it means. So you can see the parabola looks the same on that side as it does on this side. That's why this is the axis of symmetry. That's kind of where the mirror would be, where it looks the same on either side. This parabola opens up, meaning that from the vertex it goes upward. It could go downwards as well, and we'll see some examples of that. And the domain and the range are two other things you might want to know. So domain, that's just all possible x values. So that's what we mean by the domain and the function. Which x's could we put in here that are valid? Now with these quadratic equations, it turns out that all x values are valid. You know, there's no number you could stick in there that would make GeoGebra give me an error or make your calculator spit out an error if you try to calculate it. Any number you put in, you can square it. Doesn't matter how big, doesn't matter how small. So all x values are allowed. How do you write a domain? So for this example, we would say the domain is going from minus infinity all the way up to plus infinity. Okay. And you use round brackets, which are different than square brackets. You use the square bracket if x could actually be the number on the right, but nothing can ever actually be infinity. You can just go toward infinity, get bigger and bigger, or go toward minus infinity, get smaller and smaller, but you never actually get there. So that's the case for round brackets. We'll see an example of square brackets soon when we talk about the range. So range is just all possible y values. So the range for this simple parabola, it can be as small as 0. So y is 0 here at the vertex. The vertex will always be the biggest or the smallest value for y. So that's something to keep in mind. So it goes from 0, and nothing stops how big y can be. It can go all the way up to infinity. 0 to infinity. Now, because y can actually be 0, if you put in x equals 0 in that equation, you get y equals 0. So that's why you put a square bracket. If it had to be y bigger than 0 but not equal, you would use a round bracket. And there are some functions that are like that, but not this one. So square bracket on the 0, round bracket on the infinity. Always round brackets with infinity or minus infinity. Nothing can equal infinity. It's something you'll learn about limits eventually, and that's when you can treat infinity a little bit more properly. Okay, so that's domain and range. Maybe I'll erase my screen for now. And what else might we want to know? We might want to know the x-intercepts and y-intercepts. So X-intercept is where does it touch the y-axis or cross the y-axis. Here it actually touches just at one spot, and you could say the x-intercept is 0. So x-intercept is at x equals 0. And where does it cross the y-axis? Again, for this simple one, we have the y-intercept. That's at y equals 0. You can see that right from the graph. You can also solve for that. So just as a trivial example, if I want to know at what value of x does this parabola cross the x-axis, maybe this will seem a little bit backwards, but we'll do another example. The x-axis is where y equals 0, right? So you actually start by setting y equals 0 and then figure out what x's make that true. Now for a quadratic, there can be two different x's that make it true if your quadratic's like that, but this one is just touching that x-axis. So the x that solves this value is just x equals 0. The square root of 0 is just 0. Similar for the y-intercept, you want to know where does it cross the y-axis. That's where x is 0. Look, x is 0 all on that line. So you set x equals 0 to find your y-intercept, and putting x equals 0 there just gives me the y equals 0. Okay, so that's the x-intercept and y-intercept. Okay, so that's a really basic example, maybe even a little bit too simple. Let's see what happens if we change things. So in my equation right now, I've got x squared. What if I add 3 to that? You can see that moves the whole quadratic function up 3. You can also see, you can imagine if you subtract a number, it will move the whole graph down as well. So subtracting 5 moves that vertex down. So you can see that this number here is really the y value of your vertex. Let's just do one thing at a time. So we'll go and set that that vertical shift back to 0. That's really what we're doing, is shifting it up and down. And let's say we do something like x minus 5 squared instead of x squared. Now we're going to see that it moves 5 to the right. Maybe that seems backwards to you, but that's how it is. So when you put x minus 5 and, let's undo that. Oh, now I went and changed my zoom again. Okay, there's something messed up. Okay, let's go back. We had x minus 5, and we squared it. Okay, so we moved 5 to the right. I'll try to pull this down so we can see it a little better. And it just moved 5 to the right. If you add 5 instead of subtract 5, it goes left. Okay. And you can see that's just, this is really giving you the x value of your vertex. So if there's a plus 5 in there, your x value is the opposite sign. It's at minus 5. Let's do 2 of those things together. So we'll do a vertical shift and a horizontal shift at the same time. If we say x minus 2 squared plus 3, can you guess where the vertex will be? So notice it went to plus 2. So when it's minus 2, that means the vertex is plus 2. So the x value of this vertex here is plus 2. and the y value is plus 3. This one, the sign matches, plus 3. I got y is plus 3. For x, the sign is opposite. When it's minus, that's when it's at plus 2. So if I were to write this out, we can have x minus x, maybe I'll call it xv for where the vertex is, plus yv. So there's your x coordinate of your vertex, and that's the y coordinate of the vertex. Okay, so that's shifting it around, and you can see how the vertex coordinates are in that problem. What about if I put something in front of the x squared part? So let's go back to our simple function, x squared, and we'll put it all together before the video's over. But notice it goes up when I've got a positive, right now it's just x squared, so that's positive x squared. If I put minus x squared, it goes down. So negative numbers will make the quadratic the quadratic graph go downward from that vertex. And you can even put a number like 2, and that just makes it more steep, so it kind of goes up more quickly. So if I put in the number 8, it'll be even more steep. And if you put in something like a half, you kind of flatten it out more. So the smaller this number is, the more flat the graph becomes. And if it's negative, you actually flip it around so it goes down. Okay, so maybe I'll put up an equation here, and then I'll go over to a whiteboard I can draw on, and we'll find all of those different properties of the quadratic equation on the graph for what I type in. So let's try x minus 3 squared, and we will subtract 4. Can you guess where that vertex will be? Which way it will open, up or down? Let's see. So x goes to the vertex here. The x coordinate's 3, the y coordinate's minus 4. There's our 3, here's our minus 4. Okay, so I've written down our parabola function. Let's discuss this one and see how we could plot it by hand. So we're going to need a few useful points that will help us with the plot. First of all, we know the vertex will be at x equals plus 3, right? Basically, the vertex is the thing that makes this 0. So a plus 3 will make 3 minus 3, 0. So the vertex is plus 3. It's also the opposite sign of what you get here. So if that's a minus 3, your vertex is a plus 3. If it was plus 3, the vertex would be a minus 3. For the y coordinate of the vertex, you just take this number, and it should be a minus sign there. So we want, this will be, or sorry, we take this number, and we get a minus 4 there. So this just comes out the way it is. So x equals 3, y equals minus 4 is that vertex. Okay, now we need to find where does it cross the x-axis and where does it cross the y-axis. So I'll just start drawing a little sketch so I can talk about this. Here's x. Notice it crosses the x-axis, so the x-intercept has y equals 0. Right? Y is 0 everywhere along the x-axis. So we set y equals 0 in our equation, and that'll help us find where it crosses the x-axis. So putting y equals 0 up there, we get 0 equals x minus 3 squared minus 4. We need to find what x makes this true. Maybe there's even more than one of them. Actually, there should be more than one because the parabola kind of looks like that. And there's two places where it crosses the x-axis. So we expect there to be two different solutions. Let's see how that works out. We need to add 4 to both sides of this equation in order to cancel out this minus 4. Our goal is to get the squared bracket all by itself. So adding 4 will cancel that out, but I need to put it on the left side too. I need to add 4 to both sides. So here I get x minus 3 squared, then it's minus 4 plus 4, but that cancels out. So you just get 0, and you don't even have to write down the 0. Okay, now let's take the square root of both sides to get rid of the square. So we want square root of that, square root of this. Now, what's the square root of 4? It's 2, right? But did you know it could also be minus 2? So because minus 2 squared also gives you plus 4. So this, at this point, breaks up into two different equations. You can also just put a plus minus in front of there and treat it all as one equation, but I'll keep it a little bit more simple, and I'll split it up into two this time. So now I've got two different equations that x can solve in order to make this true. So for this one, if I add 3 to both sides, I get 5 equals x. And this one, if I add 3 to both sides, I get 1 equals x. So the two x-intercepts are at x equals 5 and x equals 1. And for both of them, y is 0, because that's what we put in at the start. But this is really what defines an x-intercept. That's where y equals 0. All right, let's find that y-intercept. So that's going to happen. You know, where does it cross this y-axis? That's where x equals 0. So x equals 0 on the y-axis. X equals 0. If we put that in our equation, we get y equals 0 minus 3 squared. You can put the 0 there if you want, but it doesn't matter. Minus 3 squared. Subtract 4. So y equals 9 minus 4, and that equals 5. Okay. Other question we have is which way does it open, up or down? You know, it has to go through all these points starting at our vertex, 3 minus 4, so there's kind of two ways to check this. But because there's nothing written here, it's the same as if there's a plus sign. So it's going to open up. It only opens down if there's a negative number in front of here. So let's just plot this. We've got, let's say this is where x equals 3 and where y equals minus 4. Now, you can do this on graph paper where you label every single tick, but what's important is labeling these important points. So usually when I sketch by hand, I just label the axis at the points that I want to show. So I want to show this vertex. I want to show that it goes through x equals 1 and x equals 5 on the for the x-intercepts. That's what we found. And I want to show that it goes through y equals 5 when x is 0. That's the y-intercept. So it's got to be up here at y equals 5. Okay, it starts here. It's going to go up and cross at y equals 5. And it goes like this. All right, so that's how you do the sketch. I think there was one more thing we were talking about. Oh, let's not recommend that. And that was that line of symmetry, or that axis of symmetry. That's just this line here going through. It always has the same x coordinate as the vertex. So that line of symmetry, line of symmetry is at x equals 3. It'll always be the same x coordinate as that vertex. That's the point 3 minus 4. Okay, so I think that's everything we wanted. We got the graph, the vertex, the axis of symmetry, direction of the opening. It opens up. You know, it had to go through, start here and go through there and there, so it had to open up. And we checked it opened up by that sign. Oh, we still haven't talked about domain and range, so we can write that as well. And in this case, we have a minimum value, right? So the minimum value, it really means the minimum y value is minus 4, right? That's where the vertex is. That'll be the lowest point. Quadratic that opens this way will have a maximum y value. Well, let's do that next. The domain, that's all possible x values, so that domain is, for all of these quadratic functions, it's going to be the same. Domain will be more interesting for other functions. Range are all possible y values. The lowest it gets is minus 4, and it does equal minus 4. So you put the square bracket for that one. It can go all the way up to infinity, but nothing ever reaches infinity, so you put a round bracket on that one. Okay, so that's the entire question for this function that we wrote. Let's just double check things in GeoGebra, and you can see it started at the vertex 3 minus 4, right there. It goes through x equals 1 and x equals 5 as the x-intercept, and crosses the y-axis at y equals 5. So everything we sketched turns out to be true on GeoGebra here. Of course, it looks a little nicer on GeoGebra. Okay, let's do one more that opens the other way. So this time I want it to open downward. I'm going to make a negative number there. Let's put a 2 in there just for fun as well, just to make it a little different. This time, let's go x plus 1, and let's make this one y plus 2. Okay, let's remember this, but we'll come back to it. We'll go back to our whiteboard and work it out by hand. So we had y equals minus 2 x plus 1. I forget what it is, I have to look. X plus 1 squared and plus 2. Okay, so we're expected to open down. We're going to want the vertex and the intercepts to help us with the graph first. So let's do that. Vertex. You can just read it off. It's going to be at x equals, what x makes this 0? When x is minus 1. Also, it's going to be the opposite sign of that. So we have x equals minus 1. And the biggest y will be, well, at least it's the vertex y coordinate will be this plus 2. Okay, so don't get confused with writing a coordinate in the way we're writing domain and range and interval notation. Here there's an x and a y on the left and the right, and in that domain and range we're talking about the minimum and maximum values. but it kind of looks the same. But for a point, you always use round brackets. And in that interval notation, you can sometimes use square brackets. Okay, so that's the vertex. Let's find the x-intercepts. For that, we have y equals 0, because y is 0 when something is crossing the x-axis. From y equals 0, we get 0 equals minus 2x plus 1 squared plus 2. Again, I just put a 0 in for that y, and this is what the equation looks like then. Okay, now we have this plus 2 to get rid of, so let's subtract it over to the other side. So we end up with minus 2 equals minus 2x plus 1 squared. We want to get rid of this now before we take the square root. We just want the bracket squared. So to get rid of that, you divide by minus 2. We got a minus 2 on the left as well, so minus 2 divided by minus 2 just leaves 1. And now I have x plus 1 squared. Take the square root. Here, I'll do it the fast way this time. I've got x plus 1 can be plus or minus 1. Okay, I took the square root of that, and there's two possible answers for the square root of 1, because minus 1 squared is plus 1. Also, plus 1 squared is plus 1. So there's two answers for that square root. And that's how the two x-intercepts come out. You can even get 0 x-intercepts. Maybe we should do one of those next. Okay, so let's find our two answers for x, and I'll show you how they both come out of this one equation because of the way I wrote plus or minus 1. Okay, so let's subtract this 1 to get it over on the other side. I leave this plus or minus 1 the way it is. I'll put minus 1 plus or minus 1 equals x. Okay, so I subtracted 1 from here, I subtracted 1 from there. This goes away, and then you can see the minus 1 is there. And now let's do it both ways. So for the first solution of x, I will choose the plus sign. Minus 1 plus 1 is 0. For the second solution of x, I choose the minus sign. Minus 1, subtract 1 is minus 2. And I just listed both of the possible solutions for x with the comma in between. Alright, so our x-intercepts are when y equals 0 and x is 0, or when x is minus 2. Okay, y-intercept. This time we set x equals 0, and we have y equals minus 2 times 0 plus 1 squared plus 2. So that's just putting the 0 in there. And we're going to find what y is when x is 0. And that's what the y-intercept is. So y equals 1 squared is just 1, so we get minus 2 plus 2. Well, look at that. The y-intercept is right at 0. So this one will go through the origin. Okay, let's do a little sketch. So our vertex is at minus 1 and plus 2. Say it's there, minus 1 plus 2. It needs to go through these points where y is 0 and x is 0. And it needs to go through this one at minus 2 as well. So x is minus 2 there. Okay. And if it's going to start here and go through those points, I know it's going down. It's nice to check things two ways just to make sure you got it right. I also know it's going down because of the minus sign. Okay, so other things to talk about. That line of symmetry is, right through that x vertex coordinate. So axis of symmetry at x equals -1. Domain, all the possible x values. X can be anything. There's nothing restricting what x can be. So we've got -infinity to +infinity. And range, this time x can be as little as -infinity. Those arrows going down, it can go all the way down to -infinity. And the maximum y can be is +2. That's not a minus sign, that's just my notch on the y-axis. So this is a +2 here. And y can actually be +2. It's not just less than, it can be equal to +2. So that's what the range is. In this one, we got a maximum value. There's no minimum value because it can go down forever, all the way to -infinity. So there's no minimum. Maximum is +2. We can check this in GeoGebra. You can see it's doing all the same stuff we just talked about. We've got our vertex at -1 and +2. It goes through the origin. Notice the x-intercept and the y-intercept. Y-intercept and x are the same. It's at the origin. That crosses both axes. And we also go through the x-axis at -2. Okay, let's do one more example, just because there's one more case we can get. What happens if we make this, let's say, a half times that? Let's make this +2, and we'll make this one +3. Oh, look at that. So this one, so these quadratic equations will always go through the y-axis, but notice this one does not cross the x-axis. So there's no solution where y equals 0 if you try to solve that. Let's see how it all plays out. Okay, so a half +2 and 3 are the numbers I put in. Okay, so y equals 1/2 x plus 2 squared plus 3. All right, so that vertex will be at x is -2 and y is +3. Double check I got that equation right. Yeah. Okay, and you can see the vertex matches with what we found. All right, how about those x-intercepts? Let's see what's happening with that, because it doesn't go through the x-axis. What does the algebra look like in that case? So we set y equals 0, and we have 0 equals 1/2 x plus 2 squared plus 3. Let's try to solve for x. We subtract 3 from both sides. We get -3 there equals 1/2 x plus 2 squared. Then we multiply by 2 to get rid of the half. So we got -6. 2 times the half is just 1, so that's what makes it go away. And we reach the point where -6 equals x plus 2 squared. Now when you try to take the square root of that, your calculator will complain. There is actually a sensible way to do math with that, but it involves something called complex numbers. And I don't think you'll see that until you get to university. And you may never see it, depending on how much math you take. But so at this point, you say there is, no real solution for x. You've probably heard about real numbers. Those complex numbers are not real numbers. They're a different kind of number. And because it's not a real number, it's not actually a point you can graph. So, it doesn't show up on the graph. There is a solution in terms of algebra, but it's not something you see on the graph. And there are no real solutions. So at this point, you just say no real solution. So no x-intercepts. Okay, but we will find the y-intercept. The y-intercept will be where x equals 0. When you put in x equals 0, we find y equals 1/2 times 2 squared plus 3. So y equals 1/2 times 4 gives us 2 plus 3. Y equals 5. Okay, so it should cross the graph at x equals 0, y equals 5. It will open upwards because we got a half there. Let's go ahead with our sketch. Okay, so we're at -2 plus 3 and we go up from there. And we have to cross the y-axis at y equals 5. And that's what we found here. X is 0, y is 5. And we found no x-intercepts, and that matches this graph, right? Because it doesn't cross the x-axis. So that's why there's no solution for the algebra, and that's why on the graph it doesn't even go through the x-axis. We can find the domain and range for this. Well, first of all, at axis of symmetry, that's just at x equals 2 or -2. So axis of symmetry at x equals -2. Domain, same as before. There's no x you can put in there that will, break it. Range, this time there's a minimum value for y. It goes as low as 3, right? And then it's all up from there. So the lowest point is 3. You always put the lower number on the left, the higher number on the right. It goes all the way up to infinity. Nothing will stop that quadratic from going up. Okay, so there's a video on how to handle these quadratic equations. I hope that's helpful. Let me know if there's any other things you want me to do.